In this video, I'll be looking at the Beer-Lambert law. The Beer-Lambert law expresses the linear relationship between the absorbance and concentration of a compound at a fixed wavelength. The Beer-Lambert law can be expressed by this equation, which is found in section 1 of the data booklet. So next we'll have a look at each part of the equation in more detail. So we have the intensity of the light before it passes through the sample. We have the intensity of the light after it passes through the sample. We have the molar absorption coefficient, the path length of the absorbing solution, which is usually 1 centimeter, and the concentration of the solution. Next we look at calibration curves. A calibration curve can be obtained by using a range of solutions with known concentrations and measuring the absorbance using a spectrophotometer. On the y-axis we have the absorbance at a certain wavelength. On the x-axis we have the concentration. So as we can see from this graph, the absorbance of a compound at a fixed wavelength is directly proportional to its concentration. The calibration curve can be used to determine the concentration of an unknown copper sulfate solution by measuring its absorbance with the spectrophotometer. So from the graph, we can determine the concentration of a copper sulfate pentahydrate solution with an absorbance of 0.170 at 635 nanometers. So on the y-axis, we find the point of absorbance at 0.170, and that gives us a concentration of 0.016 moles per decimeter. So let's end with a summary. The absorbance of light at a fixed wavelength is directly proportional to its concentration. A calibration curve can be plotted and used to determine the concentration of an unknown solution. This method can also be used to determine the concentration of protein in a sample, which we'll look at in the next video.